Right, that's 9 o'clock. Oh, and the doors quietly swing closed. Morning, do we all have our coffee? Can someone go get me one? Good morning. For those of you that didn't come to my talk yesterday, I hate you, but that's fine. My name is Barry Dorrans. I am the .NET Security PM, plus a bunch of other ancillary things that I just can't get rid of, which means I tell everybody how to do things correctly, and when they screw it up, I have to deal with it. You can follow me on Twitter as @blowdart. It's very sweary, I warn you now. But this is Australia, so that's fine, because swearing is a cultural thing. The Americans, on the other hand, they get a little bit upset. So today I'm going to go through 8 MSRC bulletins, MSRC being the Microsoft Security Research/Response Center, and what caused them. What we did wrong to cause these vulnerabilities and things that you might be doing wrong in your code that will cause the same sorts of things. Then a bonus advisory, I'm going to talk about how to encrypt properly and a few things that we caught before they caused the bulletin that some of you have probably done in your own code. So the way the vulnerability process works, if everyone is being well behaved, is an email goes to secure@microsoft.com with details of the problem and preferably a sample that demonstrates the problem. MSRC open a case and put it in a Dynamics system, which is really hard to use. And they route it to the product group they think are responsible. So for .NET, that means I get an email in my inbox. And I look at the report, and I try to reproduce the problem. And if I reproduce the problem, I'm like, OK, well, this seems reasonable. And then I go to a bunch of VMs, and I try and reproduce it again in all the supported versions of our product. So that's .NET 3.5, .NET 4.7, even .NET 2.0 in certain circumstances, all the versions of core. And that takes a little while. And sometimes it only appears in certain cultures or languages. We've had one bug report that only appears when your culture is set to Thai. So for all the supported languages, sometimes I will go through a bunch of various different ones. So as you can imagine, the test matrix for this is really loud. Loud? Large. Loud is me swearing. And once we're sure that we know the problem exists and is being reproduced, I go find the developers responsible for that area of code and say, look, here is your problem. Go away and fix it. The fix generally takes maybe a week and a half. For super complicated stuff, the fix can take a couple of months. And then we test the fix against all supported operating systems and all supported software configurations, plus a bunch of third-party software that we have that we know uses .NET in really, really horrible ways to try and make sure that we don't break things. And that test process can take anything from 1 to 6 weeks. Then I write the security bulletin. The fix gets pushed out internally to a bunch of random machines within Microsoft to make sure that we don't break anyone. And eventually, on a Patch Tuesday, there will be a drop of a fix. So the important thing to note here is really developing the fix itself only takes 1 to 2 weeks. It's all the compatibility testing that we do, and we still get wrong every now and again, is what sucks up the large amount of time. I know some of you will believe that we don't test our fixes at all. I assure you that we do. So I'm going to go through all of these. We're going to talk about hash DOSes, padding oracles, SharePoint, Exchange, with a little bit of a sideways into Docker, regular expressions, cross-site scripting, cross-site request forgery, Russian nation-state malware, and then just getting things entirely wrong by believing what a user says. None of these are in any particular order. They're just in the order that I managed to write demos to demonstrate them with. So, hash denial of service. How many of you saw this talk last year? Oh, good. I can treat this as a brand new audience and do my cat thing. Denial of service that was caused by parsing form inputs from form submissions in ASP.NET. When we take a form submission, or we even take any HTTP request, to be honest, we shove a bunch of things in dictionary objects, and the dictionary objects are backed by hash tables. And if anyone who has ever interviewed with a software company where the interviewer wants to prove that they know more than the interviewee, you've had to implement a hash table on a whiteboard. So the way hash tables work is it's just a way of speeding up lookups in a dictionary. So I'm going to explain this in terms of cats, because I don't like cats, because I am a dog person. Cats are evil. Dogs are just full of infinite love. Say you go on holiday and you own a cat because you're a horrible person. Let's be fair, cats own you, not you owning a cat. And you have to put your cat in a cat boarding house. And so you take your cat to the cat boarding house and say, here is my cat, please look after him. And obviously the cat boarding house wants to remember who your cat is, so when you can come back again, you get the right cat back. So they have this filing system. They have like 26 rooms, room A, room B, room C, room D. And they take the name of your cat and they look at the first letter, and if your cat's first name begins with A, he goes into room A. If your cat's first name is B, he goes into room B. So they're speeding up the lookup for when they have to retrieve the cat, because they are going to know which room they have to go to, and then they look through all the individual cats to look for the individual one that they have to pull out. And that's basically how a hash table works. Try that in your whiteboard next time you're interviewing. You'll get really strange looks. So obviously, the more cats beginning with A that there are, the longer it is going to be to retrieve your cat. So if I want to denial of service the cat hotel, I turn up with 1,000 cats and say they're all named Alan. And all of the Allens go into room A. And there's probably not enough cat cages or scratch poles or wherever cats live in. So it takes a long time to take those 1,000 cats and put them into the right slot. And then you come back again and you say, okay, I'd like Alan back. And then someone has to go into room A, get scratched because it's full of 1,000 cats, and pick up each individual one and bring it back and go, is this Alan? And you go, no. Is this Alan? And you go, no. And it takes an awfully long time. There is your denial of service, as demonstrated by cats. So the more you force everything into this single slot, there's going to be more and more CPU time, which leads to a denial of service. So this was presented in 2011 at the Chaos Communication Congress, which is a really fun conference where they don't warn you of all the things that are going to happen. Thanks, guys. So it can spoil your Christmas. It was originally targeted against PHP, Java, Python, and JavaScript. Pretty much all of these vulnerabilities are general. They don't affect just .NET. They will affect Java. They will affect Ruby. They will affect Perl. It's just I know .NET, and I have to deal with .NET. Therefore, these are what all my demos are written in. So we'll have a little demonstration here. If I go to, where's my hash DOS? There it is. Set as startup project. The way we implement hash tables in .NET or for dictionaries and dictionaries of strings is we use the hash code that the object generates. How many of you have implemented your own get hash code in any of your classes? Yeah, you're going to be nervous now. So what I'm going to do is I am going to take a string and I'm going to shove it into a dictionary. And then I'm going to take a really, really dumb string where the hash code is exactly the same, and I'm going to put it in the same dictionary, and we will see what happens. So if I hit start, it will eventually compile. OK, so there's the good hash code. I put 1 million string objects into the dictionary. And the bad hash code, where everybody's hash is exactly the same value, is going to take a demonstrably long amount of time to do. In fact, if I leave this running Certainly in my old machine, it would never finish by the time that my presentation had finished. So I'm going to Control-C out of this. So we have just basically forced all our strings to be called Alan by overriding get hashcode. So we fixed this. We fixed this by actually randomizing what string get hashcode does. So from one instance of an application to the next, string.get hashcode, when it's shoved into dictionaries, will use a seed value that randomizes it. So you can no longer say, all my cats are named Alan. And you can also fix this by not using user input, a class that you have constructed from user input solely as a key in your dictionary. For those of you that have implemented get hashcode, if you are putting these classes as a key in a dictionary and those classes are solely constructed from user input, you now have a problem. So what you end up doing is having a static value in your class that is a random value, and you feed that in as part of your hashcode calculations. So from run to the next, it is different. We always said in the documentation that hashcode may not be the same every single time you compute it. It wasn't guaranteed to be the same from one program execution to the next. But of course, none of you read the documentation, did you? We have people that have saved get hashcode in databases, and frankly, it sucked to be them. We had a switch where you could turn it off. So in .NET Framework, you can turn that off or you can turn it on. In .NET Core, you have no choice. We are randomizing the hell out of you. Because with .NET Core, we could throw away some of the bad security practices and implement the good stuff. Next, a padding oracle attack. Oracles, in this case, are not the database. It's basically just something that sits there and tells the attacker something about what they are attacking. Generally, they're called an oracle because they don't give them useful information. They just give them hints, like the Delphi of Oracle in Greece, and whoever discovered this first wanted to prove that he had a classical education. Therefore, they're oracles. So in ASP.NET, we had an endpoint which validated if a string was encrypted correctly. And we would basically say, yes, this is good, or we would throw an error. And that error is enough of an oracle to allow an attack to happen, because the time taken to build the error and return it was viewable enough over the internet for someone to build up an attack. So the way a padding oracle works is when you are using padding encryption, your data gets split up into little blocks. And the result of the first encryption of the first block gets fed into the second encryption block, and so on and so forth. And then at the end, if your data is not the exact size to be split into blocks, it gets padded out. And this padding is what ends up getting attacked. So you can tweak 1 bit in the last byte of your encrypted information and send it to a system. And if the system errors and you can measure that error, you know that you have tweaked that bit incorrectly. So you tweak it again. And you work through backwards, byte by byte by byte by byte, until you get a properly encrypted value. So what the attacker could do in this case was put in a file name, the file name being web.config. And they could just tweak each individual bit until they got the right encrypted value for web.config to push into this subsystem without ever knowing the encryption key. The encryption key never leaked. And that's what we were doing in script-resource.axd. Unfortunately, once you've managed to get web.config in there, what script-resource.axd was supposed to do was supposed to serve up embedded JavaScript from resource files in your application. It wasn't just limited to JavaScript files. It would do any file name that you give it. So as soon as the attacker sends web.config, web.config gets served back to you. And web.config, at that point in time, included the encryption keys in it, which was a bit of a problem. Because now I have the encryption keys that we are using to create authentication cookies. So I have the encryption key for authentication cookies. I can create an authentication cookie, and I can be anyone that you want to be. So we fixed this. We fixed this by making sure that scriptresource.axd only served up JavaScript files in embedded resources and nothing else. And we also fixed it by making sure there were validated signatures. The way to stop padding Oracle attacks is not to change your encryption, but to make sure that you have an authenticated signature on the encrypted data. And so you validate the signature first before you start trying to decrypt the encrypted data. And if the signature validation fails, you just say no. And the difference in timing there doesn't matter because you can't fake the signature through any of these techniques. So it used to be that we had a bunch of functions in .NET where you could encrypt or sign or encrypt and sign. When you are doing encryption, you should be doing encrypt and sign, or just sign if you don't need the data encrypted. You should never just do encrypt. Always encrypt and sign. We have a huge white paper on this that's in the docs repo that no one ever reads. So I have a demo for this that sometimes works because it's very dependent on timing, what else is running on my machine, and the internet speed. And as you're all aware, the internet speed in Australia is awful. So here I have a server that is going to accept messages that are encrypted. And here we have the attack. And sometimes this works, and sometimes it doesn't. Really, Jeremy? All right, you know what? Let's just do that. The value must be, he's made it right. Okay, all right. You know what? We'll have to do it with small fonts. Now, where does this live? CD OneDrive, documents, conference, presentations. Oh, there we go. Okay. So sometimes this works, sometimes it doesn't. Like I say, it's very dependent. So it's working backwards. And because it was written by an American, they want some very American things. And there are various ways to speed this sort of attack up. As you can see, it's got stuck there. Eventually, it'll just either die, and I restart it, and it might get a little bit further along. Oh, there we go. So what it's doing is it's tweaking each individual bit and trying to work its way backwards. And because we know that the message is text, we can sort of speed things up by doing textual analysis and trying certain values first, you know, A, E, and I first, because they're way up higher in frequencies, and then we can look at what might follow after that. And so we can speed all these things up. But eventually, Americans, they like their Declaration of Independence, plus the developer that wrote this for me thought it would be really funny. But we have, you know, this is attacked. It didn't know what the encrypted stuff was, and it would just keep sending it back and manipulating it until it gets everything decrypted without knowing the encryption key ever. And this happens a lot. It's becoming more and more frequent. It used to be that you could just do it with errors coming back from a padding oracle, but the server in this case is protected against padding oracles. It will just always return the same thing. But for languages that are exception-based, when they throw exceptions, even if they're never exposed to the end user, you catch them, it takes a little while to build the stack trace and everything else that gets bundled into an exception. And that small amount of time, which is generally under a millisecond, is still detectable by people on fast enough networks, which of course rules out the attack coming from Australia. But if an attacker gets hosted in the same data center as, say, your cloud application, their within the same network, I mean, they may be isolated a bit so it goes out and it comes back in again, but it's a short enough hop that being stuck on Australian internet speed doesn't matter. You're doing it all in the cloud. So these attacks are going to become more and more popular. And as I say, this sort of thing now is a problem for every single language that uses exceptions to cope with errors. We have been sitting on this. We sat on this until last year because we wrote a bunch of documentation, and then we went to Google, and we went to, is it Sun that owns Oracle now? Or Sun that owns Java, or is it Oracle? Whoever owned Java, and we went to the Ruby people, and we said, look, we have this problem. Your libraries, your basic class libraries had exactly the same problem with their encryption primitives. Here's what we're going to publish. You may want to consider publishing your own. I don't know if any of them ever did. We gave them a year, and after that, I'm like, I don't want to sit in this anymore. So this is a good reason for not using encryption primitives. Remote code execution, a way of sending something that executes on a remote server. This is a simple example that actually is quite .NET specific. So how many of you have used web forms? Sorry. You will be well aware that web forms have this hidden form field called viewState. And viewState is, as some people will say, it's base64 encrypted. Now, it's base64 encoded. It can be encrypted, but that's an entirely different thing. And by default, viewState is signed, so if someone tampers with it, it gets rejected. And that's the reason why you set the machine key in web.config and then have the same web.config in multiple machines. So they all have the same encryption key, so you can load balance and send things about. And then, of course, then when you have a pattern in Oracle, your encryption key gets leaked. So SharePoint decided that this was a bad thing because it was very hard for people to configure keys in web.config. So they turned off the signing of viewState, which means you could send anything you wanted in viewState, and SharePoint would go, OK. Now, viewState generally is full of things like, oh, here's what was going to be pasted in a dropdown, and so on and so forth. But it is binary formatted, serialized data. And there are classes in the .NET framework that should never be serializable, which is kind of great. And viewState is implicitly trusted. So when viewState comes back again, the viewState class will go, OK, I'm going to deserialize these and take a look at them, because it can't look at them in its serialized state. So .NET has this class called temp file collection, which is incredibly useful, I have to admit. You spin one of these collections up, and you say, give me a new temp file name, and it goes away, and it looks, and it says, yes, here is a unique file name that you can use. And when the temp file collection class is disposed, it cleans up after itself. It goes through that list of file names and deletes them. But you can add file names to that collection. File names like web.config. And then your web.config gets deleted. Your SharePoint site goes down, and probably your users are happy because they don't have to use SharePoint anymore. So let's take a little look at this one. Not that one, not that one, this one. So what I'm going to do in this one is I'm going to create a web.config file, and we'll swap over to Explorer to see it. And I'm going to create an attack file name, and I'm going to create this temp file collection. I'm going to put web.config in it. And then use binary formatter to serialize, and then I'm going to pretend to be web.config. I'm going to read this back in as if it was viewState, deserialize it, which is all viewState is going to do. And then I'm going to force garbage collection, because frankly, we don't want to wait for this. And the forcing of garbage collection will mean that that temp file collection is going to be disposed And lo and behold, everything will get deleted. So vulnerability demos. State. Okay, so there's no web.config in here right now. I'm going to run this. Okay, so I've created a web.config. Oh, look, there it is. There's nothing in it. And so I'm hitting enter. This is reading my view state. It's forced garbage collection. My garbage collection is done. And if I go back here, I have nowhere web.config, and SharePoint is done. Which, personally, I think is a good thing, but never mind. SharePoint people give me so much heartache. An Exchange did this recently. This was last month. Yeah, this was last month, so this one is new for this. Every time I give this presentation, I go through the last 3 months' vulnerabilities and go, yeah, that one looks fun. Exchange took this slightly more seriously. You see, deleting files is amusing. However, for full remote code execution, what you want to do is you want to get to the point where you can run arbitrary commands on the server that you are sending stuff to. And we can do this with binary formatter. Exchange web servers had an authenticated endpoint, so you had to have an Exchange username and password for this on the Exchange server that you were trying to attack. So it's not so bad, but it's a nice demonstration. It accepted voicemail for transcription. If any of you have ever seen the transcripted outputs from Skype for Business voicemail, you'd think that this thing just generates random data, but apparently it doesn't. And the voicemail is binary data formatted with binary formatter. So this is the demo that I don't share. I have here serialization exploit, set a startup project. So it's going to do much the same thing as we did before. It's going to take a payload. It's going to deserialize it through binary formatter, and we're going to see some bad things. So if I start this, I'm going to hit enter when I'm ready to go. And PowerShell has popped up. That's interesting. And you know, once I have PowerShell, well, it's now downloading stuff from the internet, which is quite scary, and it's executed the most horrific thing I can think of for Australia, which is England winning the Ashes. But that could be something, excuse me, something slightly less horrific, like, you know, stealing all your credit card data. Kind of a problem. I love that picture. I got booed last year when that came up. Even Docker had this problem. Docker fixed this 3 weeks ago. When the Docker system tray, it's not called system tray, the Docker notification area application sends commands to the Docker service via named pipes. And they have forgotten to set an access control on the named pipes so anyone could access them as long as they were on that machine. And their commands were encapsulated in binary formatter. And the Docker server runs as system on a machine, so you could, as a low-privileged user, start executing commands as system on a server that you were logged onto that had Docker on it, which is kind of problematic. So there are a bunch of ways to fix this. If you are round-tripping state to user-controlled space, you need to cryptographically sign the data so you can detect that it has not come from you. You don't publish your signing key on GitHub, which an awful lot of people do. Go on to GitHub, search for web.config, and search for machine key stuff, and you will cry. We threw machine key away in .NET Core and replaced it with something that's slightly safer. And you don't use any serialization formatter that allows an attacker to specify the object type to be serialized. That's what this whole thing boils down to. Binary formatter and all of these things below all allow serialized data to say, hey, I'm of type X. And if you can control what type X is, you can get remote code execution. So you should avoid binary format or fastJSON, sweet.json, JSON.NET. If you set type name handling to anything other than none, the default is none. .NET's JavaScript serializer without having a type resolver, because the type resolver then constrains stuff. And some of you will be using binary formatter. I am not going to ask anyone to raise hands for this. And you will go, I cannot change my stuff because I require backwards compatibility. Now, I know all about having to keep crap code for backwards compatibility, believe me, but backwards compatibility should not be a suicide pact. At some point, you have to abandon it and move on to something that's more secure. If you are stuck with binary formatter, you can try this. It's not as secure as switching to a type-limited serializer, but it gets you 3/4 of the way there. This can still have problems depending on the size of your classes. It may run out of memory, but frankly, a crash, an out-of-memory exception is far better than remote code execution. We make no guarantees about this. Move your formatter. But if you're stuck in binary formatter, this might be a reasonable stopgap for you. So if you take away one thing today, it's go and look for instances of binary formatter in your code and remove them. Regular expressions. I loathe and despise regular expressions because they are incredibly hard to read. And also, they're a language within themselves. Backtracking regular expressions can move backwards and forwards through the thing that they are trying to evaluate and perform loops and all sorts of other things. It is possible to get backtracking regular expressions into an infinite loop. And the way you fix that is by putting a timeout on your regular expressions. Unfortunately, .NET does not put a timeout on regular expression parsing by default. And I can't change it because backwards compatibility. So we fix this sort of thing by adding timeouts everywhere. How many of you are using regular expressions for data validation? How many of those regular expressions are backtracking? How many of you don't know whether they're backtracking or not? Thank you for your honesty. So in .NET 4.6, loads of people were like, hey, we want more data validators because we don't want to write our own validation ourselves. And someone came up with the bright idea of providing some data validators for things like email addresses using some open source regular expressions, funnily enough from jQuery. And one of these is to validate an email address. This regular expression does not exist anymore in any of our code paths. Now, personally, I think you can only validate an email address by sending an email to it, because just checking the format is not enough. So here we're going to run a regular expression against a good value, and then we're going to put in, or we're going to run a good value against the regular expression, and then we're going to put in a bad value. And we're going to run it against the email regular expression, which is this. For those of you that are using regular expressions to validate stuff, could someone explain to me what this does? Can you tell? Seriously, can you tell by reading this? This is why I hate regular expressions. This is insane. And it's wrong, because there's an awful lot more to email addresses than the jQuery regular expression, or even the regular expression in the RFC for email addresses can cope with. So if I run this, test it against the good value, result is true, test it against the bad value, and that's going to take an awfully long time to finish. And while it processes, CPU usage is going to go tick, 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 and you can denial of service a server with this. It will finish eventually. It doesn't quite get itself into an infinite loop, but it takes an exponential amount of time to parse. So we'll close that off. So we can fix this by abandoning regular expressions altogether. For the love of God, they're awful. There was checking an email address. The right way to do it is send an email. You know, there's something on one side of an @ there's something on the other side of an @ it might be an email address. Let's find out. That's how you validate email addresses. You set timeouts in all your regular expressions. There is a timeout value in .NET. There's a timeout value in Ruby. There's a timeout value in Java. Go through all your regular expressions and make sure they have timeouts. And then if you realize that none of your regular expressions have timeouts and you have like a couple of hundred of them, and you don't want to set individual timeouts, which is the correct thing to do, you can kind of cheat. For .NET Framework, you can set that value, which is a global timeout for all regular expressions which do not have timeouts. This does not exist in .NET Core. In .NET Core, go review all your code and put timeouts in manually. You don't need to take pickies. If you go to my website, all of this will be uploaded this afternoon, so you can grab everything from there. Cross-site scripting in ASP.NET Core. I don't like ASP.NET Core vulnerabilities. They are painful for you guys to patch. How many of you are using .NET and ASP.NET Core? How many of you understand how we deliver patches? How many of you think patches will come over a Microsoft Update? Some of you are lying because no one put their hands up. We do not deliver .NET Core patches over Microsoft Update, mainly because that doesn't work on Linux. And we made a promise that we would not force patches down on you so we wouldn't break your code, and you can have your code running against multiple versions of .NET Core runtime at the same time, so you can isolate and move things one by one. So you have to manually update by installing new SDKs, installing new runtimes, and pulling down new packages from NuGet and republishing, which makes developers very happy. It makes ops people like, wait, we have to rely on our developers to do the right thing. So when you choose .NET Core, you are taking that responsibility on, and I want you to be very clear about that. Monitor the announcements repos for both .NET Core and ASP.NET Core, and every Patch Tuesday, if there is something, it will be posted there, because we can't post it anywhere else because we don't deliver via Microsoft Update. So MVC encodes every piece of output by default. That's what the little @ sign does, except when you tell it not to, which is what HTML.raw does. If you see HTML.raw in your code and you are doing a review of your code, that's something that needs to be very carefully looked at. Now, in this case, it was fine when I give the sample code across to the developers to turn it into a template. And in between the stuff that I'd written and the stuff that they wrote, they changed the way some of it works, because I tend not to write idiomatic code. I don't write things in an MVC way. I don't write things in a Razor Pages way because I'm old and I started off with COBOL and Pascal. I write things in the way that makes sense to me, and I go for clarity rather than making it look like everything else does. So we had a combination here of an overbinding attack and XSS. In the in ASP.NET Core 2.0, where we added support for multi-factor auth, here we go. We generated the keys and the QR code information on a particular screen on the server side. And so the way I wrote it was it would just get shoved into the view model on every single request. And that's not idiomatic enough. So it changed where it was posted and it was bindable, so when you hit a refresh or you got an action and you got an error, it was read out of the post data that came through rather than being regenerated every single time, which was silly, because that hash, the key value was rendered via HTML raw, because otherwise I could end up with double URL encoding and it was a little bit messy and the QR code would not scan. So what Pinpoint did was he discovered this, and he likes to make me unhappy because he's French. I had to write him a check for this. We have a bug bounty for .NET Core. If you think you have something that is a security vulnerability in .NET Core, don't post it on GitHub. Seriously, if you post it on GitHub, I can't give you money. If you report it via secure@microsoft.com and it is a vulnerability, I can give you money. So if you find something that spikes your CPU, if you find something where connections never get dropped and you're running out of resources on your web server and you think it is due to a bug in ASP.NET Core and not your own code, it is probably your own code. But if you think it's a problem in our code, email secure@microsoft.com. Please don't create GitHub issues because they have to be reported to us privately before the lawyers will let me write checks. And I am generous with my checks because I have a budget. Don't get that many every year. Frankly, I'd like to spend all the budget. So the bug bounty terms are on Microsoft.com. They will give you an idea of exactly how big the checks are that I can write. And if you give us a good repo, then the check size goes up. We even extended it. About 3 months ago, we had someone report a bunch of things with docs. And docs were not covered, and I'm like, I really want to give this guy a check, so I had to go to the lawyers and say, I would like to change our terms and conditions so it will cover ASP.NET Core and ASP.NET Core docs. And I went, okay, and I'd like it backdated. And I'm like, they're like, oh. That took a little bit to sort out, but the guy got his check. It made me happy. So here we have an overbinding via model errors. Let's just type in some nonsense. I submit query. And it just comes back again. If I put the oops version in, well, the oops version now sends things. Why didn't you do it? Oh, it's an edge, and edge has a bunch of nonsense that stops this. There we go. Okay. So the oops version shoved things up in the query string, and the way .NET Core binding works, despite my efforts to stop this, because back compatibility and developers don't want to think about it, is it will try and bind stuff from, first of all, the form fields, then it will go up to the query string, and it used to go to response or request headers, but we don't do that anymore. So we could get an XSS via here, and I'm not going to tell you why XSS is bad, because I'm sure you've all seen Troy's talks, and I really don't need to go through that again. But yes, there we had XSS from a security feature that I added and was then mangled. So don't use HTML.raw. Go through all your code and look for it, and then really carefully look at where things are going from. And things that never should come from user input, you limit the binding by putting bind never on your viewModel class. And if something is generated server-side, always generate it server-side. Don't put it in your viewModel class, and stop putting it in a hidden field, which is what the viewModel is, to transport it between requests. And then we have CSRF, cross-site request forgery. So where I can send a request from one site to another site and have something happen. We have ways to protect against this. There is a cross-site request forgery token that is embedded in every single form that MVC generates. And when you submit that form, that token is checked against a cookie value that is on the user's machine. So when an attacker reads a form, he gets value 1 for the CSRF token, and a user gets value 2. So if he tricks the user, it's the wrong value and nothing matches up. And so for when you were resetting your two-factor auth recovery codes, this was done as a form originally. And someone decided the form was not idiomatic enough because state was not changing, so they turned it into a GET request. Except state was changing, it was regenerating these things. And so if you sent a GET request to this thing that reset your two-factor recovery codes, because it's a GET request, there's no CSRF tokens on GET requests, and it would reset the recovery codes, which doesn't do anything bad until you've managed to lock yourself out of your account and want to use one of your recovery codes, and they've been reset. So for things that change state, just make sure that you're using a post, and don't let people optimize security code for the .NET Core templates who don't realize the implications of this stuff. So, SOAP. How many of you have used SOAP services? So you all remember what WSDL is. It's what you've reinvented for JSON with Swagger. Oh, we're going to go to JSON. It's so much cleaner. We're not going to make the same mistakes that we did before. Oh, yes, you are. So WSDL is metadata. like Swagger, and you point a client thing at it, and it generates a bunch of code that then gets compiled and loaded so you don't have to think about writing a client yourself. .NET Framework has a WSDL parser built into it, which I did not know about until last year. And its WSDL parser takes WSDL, generates the proxy object, and then loads it in process. No one can remember why that class is in there. No one uses it. Visual Studio doesn't use it. It has its own WSDL parser. And so there was a bug inside it. There's a bug inside its valid URL. Oh, in the notes for all these PowerPoints, it has links to the researchers and the research that they did if you want to read a little bit more. And so this enabled a particular nation state to target Russian speakers in the Ukraine to compile code against their machine, because Word had this SOAP functionality that used .NET's WSDL parser that should never have been there in the first place without ever prompting the user what was going on. So you have a Word doc that has this payload, they load it up, it calls out to .NET, it compiles some code, it loads it, and it runs it. So that has been disabled in Office now. But the only way you can really fix this is don't be Ukrainian and don't piss off Russia. This was an O day. We did not know about this. It got reported to us when it was underneath active attack, which is always a joy from a security responder's point of view, but it was seriously interesting to fix. And don't write code that generates code from user input, compiles it, and runs it, which is also Swagger. And finally, the mistrusting of user input. So this one was really nice. I was so impressed by this. And this, again, is from this year. So URL helper in MVC contains a bunch of methods for generating URLs, which includes absolute URLs. So it has the host name and the protocol value in there. And that host name comes from the host header and request, because we have nowhere else to get it from. And the host header and a request can be controlled by an attacker. Now, normally that's not so bad, because all you do is you get rendered stuff back again. You get a bunch of HTML back again, and you are attacking yourself. Except for this one thing in the MVC templates where you send password reset emails. And so the password reset emails go out to a user. And so what Mikhail did was he sent a request with the host header pointing to a sample site under his control. And he sent requests to the password reset page. And so the email that was generated in the password reset page used the domain that he has underneath his control. And the email goes out, and it's been sent out by your website. It's been sent out by an IP address or a mail server that you control, so it looks completely valid. The only thing that's different is that the URL that someone is going to go to reset their password is under the attacker's control. And they can sit there and they can intercept the password reset token and then take over your account. And even better, there are certain email clients that would render the HTML in this in emails. So depending on how you do this, things will get rendered and will send GET requests, and you can do all sorts of interesting CSRF stuff about stealing tokens and stealing recovery tokens just because you are using an email client that renders HTML by default, including image tags, like the one on your iPhone. So the way you fix this is you look at your hosting, and instead of being lazy, you don't listen for any host header. You don't configure your web servers to be any host header. You limit them to the host headers that you want to listen on. So you listen to www.contoso.com and contoso.com only. Or you do a wildcard, because some people do their multi-tenancy based on URLs. But you don't look at it with the star. And you validate all your inputs according to the HTTP spec, because the other nice thing he found was we were not validating our host header, because we didn't really use it anywhere. So you could embed HTML in the host header that ended up in the email. So what I demonstrated before with the timing oracle is basically this. There is an MSRC advisory. It's that timing oracle where we don't care about results or statuses, and you can't fix it. So you don't really expose these things again. And you need to go back to adding authenticated signatures to encrypted data. There is a huge document about this. For all of you that are doing encryption in your systems, I strongly encourage you to read this and start thinking about what you've seen. So we have 10 minutes. Let's go through the silly things. I've seen this before, where people are, OK, I have MVC encodes everything for me. I'm going to do HTML encode on a title that's in a tooltip. The problem here is that it's in JavaScript, and the encoding for JavaScript is entirely different to the encoding for HTML. And whilst you can get it right by getting it in the right order, if you get it in the wrong order, you're screwed. So if you are passing things in a page and you want to pull them out in your JavaScript, a better way to do it is stick them in a div with a data tag and pull it out of the data tag, because in the div, it's just HTML encoded, and we'll do that for you. And when your JavaScript pulls it out, it's using the right encoding when it accesses it. Culture. Languages are fun. This will print true or false depending on what part of the world you are in. Now, I know Aussies have a problem with culture. Yeah, it's what you pass off. Vegemite is cultured. I've been trying to get John Galloway to eat Vegemite all week, and apparently the shit-eating grin I have when I try and serve it to him just puts him off, and I can't think why. But tweet it, tweet at John Galloway, John without an H, and say, eat your Vegemite. And I'm sure he'll do it. All right, cultures. Too many vulnerability demos. Globalization, there we go. Bless you, sir. Or ma'am, I can't see. I love trackpads until I try and have to click something. So here we go. So this is just going to do the culture comparison. And the first time it's true, and the second time the exact same code is false, because I've switched to Turkish. And in the Turkish language, there are multiple ways to represent a capital I. So that's problematic because people do this on usernames, and then you make comparisons based on usernames to make security decisions. So when you are doing string comparisons, string.compare, always choose string comparison.ordinal, ignore case. There is a code analysis or a style cop rule for this. There's even a Roslyn analyzer. But I know none of you turn these things on because they're noisy. Turn that one on. It's not just Turkey, though. An interesting thing that we found when we were doing some Linux stuff, if you are in UTF-8 in Thailand, starts with full stop, crashes on Mac and Linux because there are no punctuation marks in the Thai language. It works on Windows because Windows swallows the exception and just says, no, it doesn't start with this. Mac and Linux, it did not. It's a really, really interesting. I spent a lot of time writing HTML encoders, so I know I spent a lot of time going through the Unicode specs. But you can see it there, and it just describes how incredibly bizarre some of these things are. Yeah. It doesn't even have zero width space. It's a strange language. So this one is kind of, this one caused a huge argument at work because .NET was being blamed for it when really it was the MSIT person that had written a really silly system. And it was like a week and a half of arguments until I could prove them wrong. And I always like proving people wrong because in my head, I am 100% right 100% of the time, as my wife will attest. So Unicode has this concept of full width characters, and I know it's a little bit hard to see. You have the less than on the left, and the full width, or the American version, because I put on a couple of stone when I moved, becomes a full width version. And it is, in fact, 2 Unicode characters, and there's a lot of them. So you can see that there's like full width for most of the alphabet and a bunch of punctuation marks. And browsers know the difference. They know that this script tag is not an actual script tag. It's full width characters. And what this guy had done was he was like, okay, we're doing like HTML encoding, we're doing a bunch of stuff, and I'm going to strip it out, and then I'm going to persist everything into SQL. And when you put Unicode in SQL, you put it into varchar, right? This guy did not. He put it into varchar, and SQL was really helpful. SQL went, hey, you have full width characters. Now, I don't want you to lose data. So what I'm going to do is I'm going to take those full width characters, which are Unicode, and you're sticking in a varchar field, and I'm going to convert them to their normal width characters. So this script tag bypassed all of his filtering, and then as soon as he stored it in SQL, it became a normal script tag, and he had persisted XSS. So you don't obviously store Unicode in a non-Unicode field for this, because otherwise you want to look at it. And you don't filter. Don't try and fix problems on data. Don't try and use regular expressions, as the famous Stack Overflow question has, to parse SQL, or it's not SQL, HTML. You are doomed to failure with this. The only way to safely accept rich text really is these days to use a markdown parser and tell a markdown parser not to parse embedded HTML. Never trust anything that comes from your database, because your database could be vulnerable. Your database could have been compromised. You may have an idiot writing your database schema. So you should treat everything coming from your database as hostile, in the same way that you would treat any user input, any untrusted input, and just HTML encode it on the way out. Crypto is fun, as you've seen. I've seen this. I've seen that. More practically, people reuse their encryption keys and their initialization vectors too much. When a document or a resource, whatever you're trying to encrypt, changes, change your key. Or if you can't change your key, definitely change your initialization vector. And keys have purposes, so you shouldn't be using the same key that you are using to encrypt credit card transactions with to encrypt email addresses with. Have different keys for these things. What you can do if you only ever want to store one key is you have a master key, and then you use key derivation functions, which take a purpose, and do a bunch of fun math with it, and then generate new keys from your master key. That's what we end up doing in the data protection layer. And like I said, encrypted data needs to have your authenticated signature on the end of it before you try and do any decryption. Another fun one I've seen is people like do a bunch of hashing stuff. And they combine a bunch of data together. And so if you do it without lengths, it doesn't really work, because built-in securely is the same as built insecurely when you concatenate it. So if you are hashing multiple values, stick the lengths of those values in there before you do the hash. Path transversal. When we're uploading stuff, always use unique names. Don't trust what has come from the browser. Then there's zip slip as well, which is reasonably new when you are unzipping things. The zip format allows paths and file names. The .NET API generally, when you say unzip, gets it right, but it also allows you to get file names. And we tell you what has come from the zip file, so it may include paths, so you need to just figure out whether it's included in a path or not, and concatenate that out. Anyone that's accepting zips, beware of things like zip bombs, because a 42K file can unzip into 4.5 petabytes, which is always fun. This one's freely available on the internet, but you have to turn off your virus scanner to download it and send it to someone. Do that on your test servers, please. Don't do it on your live production data. XML is exactly the same thing. You can prevent that by turning off DTD parsing. So, in summary, sign your data. Every single piece of data that you have should have a cryptographic signature on it, whether it's encrypted or whether it's round-tripped. Sign it and check the signature first. Don't use regular expressions. For the love of God, don't use binary formatter or any of those other formatters that I pointed out. Don't set up over binding in MVC. Exclude the things that aren't meant to be bound from your view model. Always use your right HTTP verb. Don't give your templates to other people to turn into templates before they bundle them in Visual Studio. And validate your inputs, and that includes all your host headers. So never have your web server just listening for star as a host header. Start limiting these things. We are out of time. Does anyone have any questions? I think I can take one or two. Or are we all just too scared, or we don't want to admit things? All right, I think we're probably just all too scared, don't want to admit things, or like, screw you, Barry, I want another coffee, it's 10 a.m. Thank you very much for coming, have a good day.